I want to show you a quick way to re-index the sums. So here's what I would do. I would look, and I look here, and n is starting at 1. And over here, when I re-index it, I need n to start at 2. So I need to add 1 to get from 1 to 2, right? I also need to add 1 to get from 4 to 5. So like if I add 1 here and add 1 here, then I will end up with the starting point and ending point that I would like, right? So 4 plus 1 goes to 5, and n equals 1 plus 1 is the same as n equals 2. So I added 1 to my starting and ending times, and what I need to do now is I need to subtract 1. I don't know if you can kind of see it here, but I need to subtract 1 from n on the formula for the actual term. So here I'll have 1 over n minus 1 times n minus 1 plus 2. Okay, which is the same as the sum n equals 2 to 5 of 1 over n minus 1 times n plus 1. Okay, let's look at the second one here. Oops, let me erase this. So again, we can kind of see what did we do here. To go from n equals 0 to, the point is that I'm supposed to start at -2. And I need to figure out the upper term for my sum, and I need to figure out, or the upper boundary for my sum and the term for my sum. Let's see here. The upper limit, I guess, is what that's called. So how do I modify this? So instead of starting at n equals 0, I want to start at n equals -2. So I need to subtract 2. So I'm going to subtract 2 from my starting index and subtract 2 from my finishing index. So this means that this should be a 5. And now since I subtracted 2, to counterbalance that, I'm going to add 2 on the inside to n.
It's 1545.
Okay, so I should have over here pi to the n plus 2 in the numerator and 3 to the n plus 2, right, plus 1. So we'll get the sum n equals -2 to 5 pi to the n plus 2 over 3 to the n plus 3. Okay, and now we've got one last problem here. So let's see here. How did 7 change to 9? We added 2. So then instead of n starting at 0, n should start at 2. Okay, and then to compensate for this, I'm going to deduct 2. So we'll have pi to the n minus 2 in the numerator, and then 3 to the n minus 2 plus 1 in the denominator. So we have the sum n equals 2 to 9 pi to the n minus 2 over 3 to the n minus 1. So we can notice that all three of these expressions are exactly the same. The sum from n equals 0 to 7 of pi to the n over 3 to the n plus 1. That's the same as the sum from n equals 2 to 9 of pi to the n minus 2 over 3 to the n minus 1. And that's the same as the sum from -2 to 5 pi to the n plus 2 divided by 3 to the n plus 3.